Hello everybody, this is our second topic, nomenclature of coordination compounds. Your learning objectives are writing the formula of mononuclear coordination compounds, name of mononuclear coordination compound, and name and formula of polynuclear complexes. In writing the formula, we follow several rules. First of all, the symbol of the central atom is written, anionic ligands come next, and then the neutral ones. Within each category, alphabetical order of the first letter is followed. Ligands containing C and H are only grouped under C. For organic ligands containing heteroatoms, the position is determined by the alphabetical sequence of the heteroatoms. If two ligands are present with the same defining atom, one with fewer such atoms precedes that with more. When the number of the defining atoms are same, subsequent symbols are used to determine the sequence. Thus, C5H5N precedes NH3. The entire coordination entity is enclosed within the square brackets. Common abbreviation for the ligands may be used. So, you can take your time to do this, to solve this problem. Suppose we have a coordination complex where the cation is sodium and the anion is tetravalent platinum complex coordinated to one ammonia, one nitrite, one bromide and one chloride ion. Write the formula. Here the answer is given. Nomenclature of coordination compounds. Cation is named before the anion. Inside the first coordination sphere, ligands are named before, followed by the metal ion. When more than one type of ligand is present, they are named alphabetically. However, prefixes used for numbers are not considered in alphabetical preference. Thus, the position of the dichloro is determined by the alphabet C, while diphenyl arsine is determined by D. The number of the ligands is indicated by the prefixes mono, di, tri, etc. However, if the ligand itself contains those prefixes of complicated nature, then a second set of prefix of bis, tris, tetracis, pentacis, hexacis, etc. are used. Say in this molecule NiN2Cl2+, this is ethylene diamine is represented by bis ethylene diamine. Naming of the ligand. For negatively charged ligand, both organic and inorganic, and O is added after the name of the anion. Say I to ido, I to ito, A to ato. These are the example. Azide to azido, chloride to chloro, etc. Naming of the inorganic anionic ligands containing numerical prefixes, triphospho and thio, seleno, etc. of oxyanions having more than one oxygen atoms are kept in enclosing mark. Neutral and cationic ligands name are used without modification and placed within the enclosing mark except for aqua, amine, carbonyl and nitrosyl. Ambidentate ligand, the donor atoms has to be specified with italics after its name. Thiocyanate ion coordinated to sulfur is written as thiocyanate S, when to nitrogen it is thiocyanate N. Oxidation state of the central metal ion is designed by the Roman numerical as this. No space is left between this number and the name of the central metal. Alternatively, the net charge of the coordination entity may be included in the parenthesis in Arabic numbers followed by the charge of the sign. For a negatively charged complex ion, suffix 8 is added after the name of the metal. Say here cobaltate. Okay. Consider the following example. This one, it has cobalt oxidation state +3. There are 4 ammonia molecules, 1 chloro, 1 bromo ligand, and so the name of the complex is tetramine bromo chloro cobalt 3 chloride. Here are a few exercises which you can follow. Bridging ligands between the two metal ions have the prefix mu. Say for this molecule, this is a binuclear complex of cobalt being bridged by one amido ligand and one hydroxyl ligand. So They are named as mu amido mu hydroxy bis tetramine cobalt 4. When both the cation and anion of a complex are coordination entity like this, PTPY4, PTCl4, this is tetrahydropyridine platinum to tetrachloroplatinate. Okay, so with this we finish here. Thank you very much for listening.